In this video, we're going to talk about how negative signs affect the transformation and graphing of trigonometric functions. And by the end of this video, you're going to be able to easily handle negative signs, whether they appear outside of the function, as shown here, internal to the function, namely within the parentheses, or in both locations. We're going to start out with an evaluation of the cosine function. And I'd like to first examine it using expanded ones and zeros. When I graph these transformations, the first thing I do is set up the middle of the graph. And that is determined by taking the normal middle, which is y equals 0, and adding or subtracting based on the vertical shift. So here there is no vertical shift, so we're going to start at y equals 0. Next, I'd like to determine the minimum and maximum of the graph by using the amplitude. The amplitude can be found by taking the absolute value of the a value, which is located here. So here, our amplitude is going to be the absolute value of 1, which is 1. So we're going to go up 1 and down 1, yielding a maximum of +1 and a minimum of -1. The next thing is to determine the period. Recall that the period of the normal cosine function is going to be 2 pi, and we're going to divide the normal period of the function by the absolute value of the b value. So the absolute value of b is going to be the absolute value of 1, and we are going to remain with a period of 2 pi. Next, I take the period of this transformed function and I multiply it by 1/4. And that gives me the steps of the graph, or the scale that we're going to use to help plot our points. So the 1/4 marks are going to be at pi over 2 or 2 pi over 4. To find the starting point of the graph, I take what's in the parentheses and I set that equal to the normal starting point of the graph. So normally, the cosine function starts at 0. So I take what's in the parentheses, in this case 1x minus 0, and I set that to the normal starting point, and we solve for x. So here we're going to get 1x equals 0 and x equals 0. So no change in the starting point, and that's not surprising given the fact that we are graphing indeed the parental function. At this point, I find the end of our graph. To find the end, you take the starting point and you add the period of this transformed function. So our starting point is going to be 0. We're going to add the period, which is 2 pi, and our ending point is going to be at 2 pi. Okay, folks, now we have everything we need to graph our function. We set up the axes, and the first thing I like to do is graph with a dotted line the middle of the graph. So recall, because there's no vertical shift, our d value was 0. This is going to be the middle of our graph, and I label it y equals 0, but this is not a horizontal asymptote. Next, we plot the minimum and maximum values. In this case, we're going to be at +1 and -1. I then plot the start of the graph and the end of the graph, and I divide this into 4 segments. And we're going to march forward based on 1/4 of the period. So here, 1/4 of the period is pi over 2, so we're going to use those values to set up our scale. I'm going to be marching by 1/4 of the period. 2 pi, so that's 1 pi over 2, 2 pi over 2, 3 pi over 2, and finally 4 pi over 2, which is 2 pi. Now, very importantly, cosine, the parent function with no negatives involved, as shown here in yellow, is going to start at its maximum. So when we're at the starting point with respect to our scale, with respect to our input, our x-axis. Our starting point is 0. We will be at the maximum point. Next, 1/4 of a period later, the graph is at the middle. Where is the middle of this function? None other than y equals 0. 1/4 of a period later, we are at the minimum. 1/4 of a period later, we are back at the middle. And finally, we are at the maximum. So that's why the 1/4 period marks are so important in graphing the cosine function. Now that we understand the parent function of the graph y equals cosine of x, let's use a similar technique to graph this transformation. The first thing I like to do is establish the middle of the graph based on the vertical shift. So here we're going to have a vertical shift of +2, which is going to yield a middle of the graph at y equals +2. Next, I take the amplitude, or I should say the absolute value thereof, and I'm going to go both north and south 2 units to establish a maximum at y equals 4 and a minimum at y equals 0. At this point, we're going to find the period of the function. The period could be found by taking the normal period of the cosine function and dividing it by the absolute value of the b. Here, b is 1/3. So the intuition tells me that this particular transformation is traveling 1/3 as fast as the normal cosine function, which means it's going to take 3 times as long. And indeed, when we divide 2 pi by 1/3, we get a period of 6 pi. Next, I like to divide the period into fourths, and I'm going to use those 1/4 period marks to establish my scale on the x-axis of my graph. So the easiest way to divide this into fourths is to simply multiply the period by 1/4, and that gives us 6 pi over 4, or 3 pi over 2. So that is how we're going to set up our scale, with either 6 pi over 4 or 3 pi over 2 advancements, depending on what the denominator is of our starting and ending points. So I'm going to put those there. Next, we're going to establish the starting and end points. The start point is found by taking what's in the parentheses, okay, right in here, and we're going to set that equal to the normal starting point of the cosine function, which is 0, and then we're going to solve for x. That's going to give us 1/3 x equals positive pi over 2, 3 pi equals 2x, and x is going to equal 3 pi over 2. So this is going to be our starting point. To find the ending point, to find the ending point, we're going to take the starting point of this transformed function and we're going to add it to the period of this transformed function. So to find the end is going to equal the start plus the period. Our start is at 3 pi over 2. We're going to add the period, which is 6 pi, which is also known as 12 pi over 2. And that's going to yield an ending point of 15 pi over 2. Now that we have our middle, we have our minimum and maximum, we have our starting and end point, we may proceed to the graph. Okay, when I graph, I like to first set up the middle and then my minimum and maximum points. Okay, so recall the middle of the graph based on the vertical shift is going to be at y equals positive 2. So I put a dotted line here at y equals 2, and I write down that this is not a horizontal asymptote. Next, we're going to take our minimum and maximums that we determined by applying the amplitude. Recall our maximum is going to be at 4 and our minimum is going to be at y equals 0. Next, I'm going to place my starting point at 3 pi over 2, my ending point at 15 pi over 2. I'm going to divide this into fourths. And then I'm going to take this number, and from the start, we are going to march at 3 pi over 2 intervals. So next, we're going to have 6 pi over 2, 9 pi over 2, and 12 pi over 2. The other way to do that, folks, is to take the numerator of the starting point and the ending point, add them, and divide by 2. So in this case, we would have 3 pi plus 15 pi gives us 18 pi divided by 2 would yield 9 pi, and similarly 9 plus 3 divided by 2 gives us 6, and 9 plus 15 divided by 2 would give us 12. So those are the two ways to determine the 1/4 scale. Folks, we are ready to now plot points. Cosine function normally starts at the maximum. Well, it turns out this negative sign means that we start at the minimum. So at the starting point of this function, because the negative is on the outside, because this negative is external, we're going to start at the minimum. So we know our starting point at 3 pi over 2 would be at the minimum, which is at y equals 0. 1/4 of a period later, we will be at the middle of the graph. 1/4 of a period later, we would be at the maximum, back to the middle, and then back to the minimum. So this is what our graph looks like. So in summary, this negative sign yields the change from starting at the maximum to starting at the minimum. Now folks, let me tell you why this makes sense intuitively, and we're going to use this going forward when we look at the cosine function. Do you remember how we determine the starting point? We set what was in the parentheses equal to 0, and we solve for x. We determined our starting point. So if we go backwards and we say, okay, we're trying to figure out what is the y value at the starting point. Well, if we were to insert x equals 3 pi over 2 into the x value, we know what this outcome would be. It would be 0. That's how we found this to begin with. Folks, what is cosine of 0? It's none other than 1. So this becomes -2 times 1 plus the vertical shift, and in this case it's going to be 0. So that's how you do these problems. You consider this 0, and then it's going to turn out that this a is going to be being multiplied by 1, and then you're going to add or subtract the vertical shift. We are going to use that method in the subsequent graphs. Let's go ahead and check our work using Desmos, the graphing calculator. Before we go there, again, quickly to review, our starting point at 3 pi over 2, we are at graph minimum, which is 0. We move to the middle, which is y equals 2. Then to the maximum at the mid-period point, which is y equals 4. So let's take a quick look at the graph. Here I've entered the line y equals 2 in a dotted fashion. Here's our starting point, 3 pi over 2. We're at the graph minimum, which is 0. Quarter of a period later, we are at the midpoint, which is y equals 2. Then we're at the maximum at y equals 4. Back to the midpoint back to the minimum. So this graph confirms. Let's now take a look at this transformation, which has the negative sign within the function. Recall that cosine is an even function and that it is symmetric about the y-axis. And when we have an even function, f of negative x equals f of x. Therefore, we anticipate that the negative within the function is going to have no effect, and this transformed function is also going to start at the maximum point, as if it were the normal parent function. Let's go ahead and graph this using the technique we used on the previous example. And recall, we are going to establish the starting point of our graph by setting that equal to 0. So if we go in reverse and we put the starting point in for x, we know this is going to end up 0. Therefore, this whole brick, yellow brick right there, is going to be cosine of 0, which is equal to 1. Therefore, we anticipate that our starting point, we're going to have 2 times 1, which equals 2, minus 1, which equals positive 1. So based on the previous graph, we are anticipating that at the starting point, we're going to get a value of y equals positive 1. So let's see if that is what transpires. First, let's establish the middle of the graph. The middle of the graph is going to be determined by the vertical shift, which is here at negative 1. So the middle of the graph is going to be at y equals negative 1. The maximum is going to be 2 units above and the minimum 2 units below. We know that because the absolute value of the a value, namely our amplitude, will be 2. So 2 units above would yield a maximum of plus 1, and 2 units below we will be at negative 3. So these will be our minimum and maximum values respectively. Recall, this is what we anticipate the starting point to be. Therefore, we are predicting that the starting point will be at the maximum, meaning this negative plays no role in how this graph starts. Let's now look at the period of this function. The period is determined by dividing 2 pi, which is the normal period, by the absolute value of the b value here. So we would be dividing it by 3. And that makes sense because this 3 here indicates that this cosine function is traveling rapidly. Therefore, if it's traveling 3 times as fast as the normal cosine function, its period is going to finish in 1/3 the time. I'd like to divide the period into 1/4 segments because that makes it easier to set up our scale. So that's going to be 2 pi over 12 or pi over 6. Next, we're going to establish the start and the end of our transformation. The start is determined by setting that equal to 0, namely what is inside of the parentheses. 0 is the normal starting point for the cosine function, and we are going to get a starting point for this transformed function of pi over 3, or this can be written as 2 pi over 6. We are now going to take the starting point, let's use pi over 3, and we're going to add the period to that, which is 2 pi over 3, to get our ending point, which is going to be 3 pi over 3 or pi. We now have what we need to establish our graph. I'd like to plot the middle of the graph first. Recall, this dotted line is the midpoint of the graph. It is not a horizontal asymptote, and that's going to be at y equals negative 1. Our maximum point is going to be at positive 1, and our minimum point is going to be at negative 3. We are now going to set up our scale. Our starting point is going to be at 2 pi over 6. And our ending point way out here is going to be at pi, also known as 6 pi over 6. We're then going to divide the scale into fourths, and we're going to march by this value, which is 1/4 of the period. So we're going to start here, and we're going to go pi over 6 to each of these tick marks. So this is going to be 3 pi over 6, 4 pi over 6, 5 pi over 6, and finally 6 pi over 6. Our prediction, based on what we talked about above, is that we will be starting at x equals 2 pi over 6 with a y value of +1. Next, the cosine graph goes to the middle. The middle of our graph is that dashed line, which is y equals -1. A fourth of a period later, we will be at the minimum, which is y equals -3 here. Next, we go back to the minimum of the the middle of the graph, and then finally back up to the maximum. So this is what we anticipate our graph to be based on what we've discussed. I went ahead and graphed that on a calculator. Let's just quickly review. Our starting point is 2 pi over 6 or pi over 3. We are at the graph's maximum value, which is +1. Next, we're going to drop to the middle of the graph, y equals -1, and then down to the minimum, which is y equals -3 at 2 pi over 3. So here we go. I went ahead and entered y equals -1, and that is the middle of our graph. Our starting point, recall, is going to be at pi over 3 or 2 pi over 6, and there we are. We are at the maximum of +1. Next, a fourth of a period later at 3 pi over 6, otherwise known as pi over 2, we were at the middle of the graph. Then we go to the minimum, which is -3. That was at 4 pi over 6 or 2 pi over 3. So we see, folks, that this graph matches what we just had on our chalkboard. Let's now take a look at this cosine transformation where we have negative signs both inside the function as well as outside of the function. Now recall, based on our previous two examples, we would anticipate that the starting point is going to be 0, which means when we plug the starting point of this transformation in for x, this parentheses is going to become 0, which means we're going to have the cosine of 0, which is 1. So we're going to have -2 times 1 is -2 plus 1 is going to be -1. So that's what I'm going to predict our starting point is going to be. Let's go ahead and graph this. First, establish the middle point of the graph. That's going to be based on the vertical shift. Here, that's +1. That's our middle. We're going to go down and up based on the absolute value of this coefficient. That means we're going to go up 2 and down 2. That's going to put us at -1 for the minimum and +3 for the maximum. Therefore, it looks like our graph is going to start at the minimum. Let's look at the period of this function. We're going to take the normal period, which is 2 pi, and divide it by the absolute value of b, and we're going to get 2 pi over 3 as our period. And that makes sense because this graph is traveling 3 times as fast as normal, and we're going to finish the period in 1/3 the time. Let's now divide the period into 1/4 segments. 2 pi over 3 times 1/4 is going to give us 2 pi over 12 or pi over 6. We're going to use that to divide our y-axis when we build our graph. Our starting point is going to be -3x plus pi set to 0. That's going to give us -3x equals -pi, and x equals positive pi over 3, otherwise can be written as 2 pi over 6. Our ending point is going to be our starting point, which is 2 pi over 6, plus our period, and our period is 2 pi over 3 or 4 pi over 6, and that's going to put us at 6 pi over 6 or pi as our ending point. We are now ready to graph this function. Recall the middle of our graph is going to be at y equals positive 1. Our maximum is at y equals plus 3, and our minimum is at y equals negative 1. Our starting point was 2 pi over 6. Our ending point was 6 pi over 6. We're going to divide this into fourths. We divided our period into pi over 6 segments, so we're going to march pi over 6 for each quarter segment. As shown. Okay, our starting point, 2 pi over 6, we're going to be at negative 1. A fourth of a period later, we're going to be at the middle of the graph. Next, we're going to go to the maximum, which is positive 3, back to the midline, y equals 1, and then back to the minimum. So folks, this will be your graph. Okay, let's see if we're right. I went ahead and graphed it underneath. Let's see. Okay, so we have the middle of the graph at y equals 1. We're starting off at 2 pi over 6, otherwise known as pi over 3, and as you can see, we are at the minimum. We then go to the middle, which is pi over 2, the maximum 2 pi over 3, back to the middle, back to the minimum. So folks, in summary, when we look at the effects of negative signs on the cosine function, we find that the negative on the outside causes us to start at the minimum. So regardless of whether you have a plus or a minus on the inside of the function, that negative is going to cause us to start at the minimum. So let's go through the parameters. On the outside, if you're positive, okay, let's say you have x here. Okay. If you're positive, you're going to start at the maximum. If you have positive, negative, you're still going to start at the maximum. If you have negative, positive, you're going to start at the minimum. And if you have negative, negative, you will be at the minimum. The big take-home message is at the starting point, that's going to be 0. So you're going to have the cosine of 0, which is 1. So you're going to have the sine of whatever is outside. I should say, the sine of the coefficient that's outside is going to determine whether or not you're going to be at the minimum or maximum. Look, here it is right here. Doesn't matter what's here. If you have a plus, you're going to be at max. Plus is max, minus min, minus min. This is going to be 0 at the starting point for cosine. That's the take-home message.